Today I will discuss the drop and hardness test for grease. Let us determine what is grease. Grease is a thick, oily substance which is put on the moving parts of car and other machines in order to make them work smoothly. Addition for that, grease helps to reduce frictions, thus higher efficiency, reduces wear, reduces heat build-up, reduces sounds, helps cooling and heat transfer, and seal to prevent moisture and particles. The grease composition. There are three components that form lubricating grease. These components are oil, thickener, and additives. The base oil and additives package are the major components in grease formulation, and such as exert considerable influence on the behavior of the grease. The thickener is often referred to as a sponge that holds a lubricant, base oil plus additives. As we see in the image, the lubricating grease is divided into three: the base oil, thickener, and additives. The base oil, the percentage of it is ranged from 70 to 95%. The example of base oil is mineral oil, synthetic fluid, plus the thickener. Thickener range from 3 to 30% that has example of simple metal soap, complex metal soaps, non-soap thickeners, plus additives, which is range from 0 to 10%, and it is equal to lubricating grease. And I will show you how lubricating grease is made.
Herschel, how grease is made. Grease is the lubricant choice when an oil feeding system isn't suitable or practical. The making of grease can be compared to making slippery, slimy mud, but instead of water and fine sand, we use oil and metallic soap thickener. Oil is heated in a vat and the metallic soap thickener is added at a specific temperature. It is mixed and sheared into the oil. A purpose-designed additive pack consisting of extreme pressure, EP, or anti-wear additives, antioxidants, and rust preventatives is mixed in to enhance the grease's performance for specific applications. Solid lubricants are added to applications where superior lubricity and anti-wear properties are required. Finally, the grease is passed through a gauze filter at about 130 degrees Celsius to remove any unwanted particles or contaminants, and is pumped into drums where it is cooled before packing and shipping. Herschel, the winning formula.
I will tell you the common application of grease. Machinery that runs intermittently or is in storage for an extended period of time. Machinery that is not easily accessible for frequent lubrication. Machinery operating under extreme conditions such as high temperature and pressure, shock loads, or slow feeds under heavy load. Worn component. Functional properties of grease. Grease functions as a sealant to minimize leakage and to keep out contaminants. Grease is easier to contain than oil. Grease holds solid lubricants in suspension. Fluid level does not have to be controlled and monitored. Drop test of grease. The dropping point of a lubricating grease is an indication of the heat resistance of grease, and is the temperature at which passes from a semi-solid to a liquid state under specific conditions. It is dependent on the type of thicker used and the cohesiveness of the oil and thickener of a grease. The dropping point The upper temperature limits at which a grease retains its structure, though is not necessarily the maximum temperature at which a grease can be used. Dropping point is used in combination with other testable properties to determine the suitability of greases for specific application and for use in quality control. I will show you a video in dropping point of grease.
Nye Lubricants performs a variety of tests in-house on our lubricants. A full complement of laboratory equipment enables us to complete qualification testing to ensure the design and performance requirements of your application are met. The test featured in this video is dropping point, also known as ASTM method D2265. The dropping point of a grease is the temperature at which it passes from a semi-solid to a liquid state. The dropping point test determines the cohesiveness of the oil and thickener of a grease. Dropping point tests are used for quality control to verify that the soap structure has been formed correctly and will withstand high temperatures. The test begins with a technician smoothing a thin film of grease into a sample cup. The weight of each sample will vary depending on the density of the grease. The cup and a thermometer are placed into a test tube. The thermometer measures the temperature in the sample cup without coming in contact with the grease. The entire apparatus is placed into the dropping point test rig. The test rig has a heater block on the bottom and can accommodate 6 different samples at once. The technician monitors the entire test apparatus as it is slowly heated in order to ensure that the heater block temperature and the sample temperature remain within 3 degrees Celsius of each other. As the temperature increases in the test apparatus, a drop of oil will fall from the cup to the bottom of the test tube at the temperature at which the thickener can no longer hold the oil. When this occurs, the technician will record both the sample and heater block temperatures on the thermometers to the nearest degree. To calculate the dropping point of the grease, the equation would appear as follows. The recorded temperature of your sample is subtracted from the heater block temperature. 226 degrees Celsius minus 223 degrees Celsius multiplied by 1/3 equals 1 degree Celsius, and that value is added to the sample temperature to determine the dropping point. 224 degrees Celsius would be the dropping point. A dropping point is most often performed on any soap-thickened grease. Soap-thickened greases consist of simple and complex soaps. Soap-thickened greases are most often used in bearing applications in the automotive, industrial, and aerospace industries.
The common types of grease and characteristics. Dropping point of a grease. The dropping point of the grease is not the same point as the useful temperature limit of the grease. A good rule of thumb is to consider the dropping point less 50 degrees Celsius as the useful temperature limit. As we see in the table, there are different types of grease, and each type there are dropping point limit and maximum service temperature. Hardness test, a test to determine the resistance of materials, exhibits to permanent deformation by penetration of another harder material. The application of hardness testing enables to evaluate materials' properties such as strength, ductility, and wear resistance. It also helps to determine whether a material treatment is suitable for the purpose required. Consistency describes the degree to which a semi-fluid or semi-solid materials resist deformation by an applied load. Consistency measurements. It is used to determine the degree to which a material resists deformation by an applied force. NLGI consistency number, or Natural Lubricating Grease Institute, expresses a measure of relative hardness of a grease used for lubrication as specified by standard classification of lubricating grease established by NLGI. Grease properties. Grease are classified into 9 consistency grades: 000, 00, 0, 1, 2, 3, 4, 5, 6. Established by NLGI. NLGI number 000. Greases are nearly fluid, while it is going to NLGI number 6 are nearly solid. Cone penetration test ASTM D217 measure grease consistency under prescribed conditions. A standardized cone is allowed to drop into the grease for 5 seconds, and the level of penetration in tenth of millimeter is measured to determine its NLGI consistency number. The higher penetration number, the lower consistency. I will show you a video on how they use cone penetration method to perform the hardness test for grease.
Nye Lubricants performs a variety of tests in-house on our lubricants. A full complement of laboratory equipment enables us to complete qualification testing to ensure the design and performance requirements of your application are met. This video will feature penetration tests. Penetration tests are conducted by Nye technicians in order to determine the stiffness of a grease. The P0, or unworked, and P60, or worked penetration tests follow ASTM D217 method for full scale, or ASTM D1403 method for half scale or quarter scale. They are 2 of the 4 required tests performed on every single batch of grease at Nye prior to shipping. The penetration test begins with the grease at 25 degrees Celsius plus or minus 1 degree Celsius being leveled into a cup. The sample size and cone weight for this test are determined by your application's needs. Using a penetrometer, a cone is dropped into the cup for 5 seconds, creating a hole in the grease. The technician records the depth in 1/10 of a millimeter of this hole. This value is known as the P0, or unworked penetration. The grease is then sheared using a mechanical worker through 60 double strokes, simulating the use of the grease. When this is completed, the technician repeats the cone test to determine the P60 value, also known as a worked penetration. Nye technicians can also carry out P10,000 and P100,000 tests, depending on the application's specifications. The penetration values of P60 are rated using the NLGI grade chart from 000 to 6. These values determine the stiffness of the grease and how a grease will react over time to service and wear. The higher the penetration value, the softer the grease. The lower the penetration value, the stiffer the grease. A grease that is too soft may migrate away from the area that needs to be lubricated. A grease that is too stiff may not effectively migrate into those areas that need to be lubricated.